Okay, so it's great to be here. Thank you all for coming, and thank you for having me here to spend a few minutes talking about 5G and Internet of Things. A wonderful presentation before me really sets up the stage for machines and how machines interact and how we should interact with machines and so on. A lot of time we spend at Qualcomm trying to build the technology that goes inside these machines. You don't see us making the machines themselves, but I like to tell people we are plumbers. We build the plumbing so you can build the houses. So let me talk a little bit about that in that context. We're actually in the middle of this huge technology phase of Internet of Things. You know, Internet of Things is a term that's gotten used quite a bit now in the last few years, and it means a lot of things to a lot of different people. The way I like to think about it, I like to describe it, is actually fairly simply, it's about connecting all those things which you are not normally used to connecting. And let me pause and say what you're normally used to being connected are PCs and phones and so on. But if you start looking at all those other things that lie around your house or in the infrastructure, what happens when those things get connected and connected to each other, connected to the internet, connected to the web, and do have processing on them? How do they change in terms of their functionality, and how do they change in terms of what they can do for you? So, I spent a lot of my years in the industry in consumer electronics, and then on cell phones. And a couple of years now, I've been working on this IoT business. It's been an amazing journey, and a journey where the speed at which we are connecting devices is really unprecedented. And for us at Qualcomm, we see this first because we sell chips. So what we sell goes into these products, and then people start making the products with those chips, and they come out. So by the time you see these products in the industry, we've probably been at it for at least two and a half to 3 years. So we are actually now, last year, we said, we shipped over 1.5 billion devices, all chips already into Internet of Things devices, which actually is a very, very large number for just having started doing this a couple of years ago. And hopefully, I'll talk to you a little bit about where those things are going and what those things are doing, and so on. And we find that our scale of shipping these products in mobile has helped us, quickly help all these other devices get connected. So what do I mean by that? In mobile, there are three probably elements of technology in mobile. When I talk about mobile, I talk about mobile phones, maybe tablets, PCs. You can think about it that way. These are mobile devices. Connectivity, being connected to something all the time, I think it makes a big difference. As someone else was saying, what do you do with your phone when it's on airplane mode? It's kind of hard to imagine what you do with it, except listen to music. And then there's computing, where you do some processing at the edge of the device. The device itself does some calculations. And then the concept of security, where you want to trust the device you have is secure, and the information there is secure, and it's not a portal to somebody wanting to do something malicious with it. Those are kind of the three pillars, if you will, on which we built mobile computing platforms in the industry. Now we find that in IoT, those exact same three things are really, really important. You need to make sure the device is connected. You need to make sure the devices have the ability to compute and do something useful. And you got to make sure that these things are secure. Now, the reason we've been able to ship this much devices in such a short period of time is that this technology of having connected computing and secure devices is something we did in mobile. And mobile has been all about scale. I mean, there's 1 billion cell phones we ship every year. And it's unbelievable the number of things we ship. And the time to market is measured actually in weeks. We've now seen products where we get our chips out, and customers are able to get their phones out in a couple of months from the time they get the chips from us. So everything has accelerated tremendously, and a lot of integration inside that. If you look at your phone today to your phone, what it was 10 years ago, you can see how much technology is integrated into that. And because we were able to do that, now we are able to use the same technology into this IoT stuff, and that's why it's accelerating as fast as it is. For sure, one of the reasons. Now, we are shipping a lot of product, and a lot of the IoT devices are working on 2G, on 3G, and 4G. But we can see now that this is going to be a problem. We can see that the bandwidth at which we are consuming these devices are consuming the bandwidth is going to be a problem. And there's a few other issues with the current technologies. If you want to use the IoT devices in mission-critical applications, like an autonomous car that needs to make decisions real time, and you want to have massive Internet of Things where you got multiple billion devices connected at the same time, sending out information, the current technologies, the current network topographies, and the current standards won't scale very well. I mean, for sure, you can make them work, and we do use them quite a bit on 4G, LTE, and so on. But we find that we'll need to define some new standards, and that's where we are spending a lot of our energy in defining the 5G standard to handle these enhanced mobile use cases, mission-critical applications, and the massive Internet of Things. I'm going to spend a few minutes talking about each of those and maybe kind of motivate a couple of use cases and tell you where the standard is. So a lot of excitement around 5G. We actually sponsored this study to see how big is this 5G and what will be the kind of impact it will have on a global scale when we get this done. At Qualcomm, we've been there from 2G to 3G to 4G to 4G LTE and so on to 5G, so we have some experience in multiple generations. There is a study that we commissioned that said the 5G economy, and we feel there's by 2035, 5G economy will have delivered up to 12 trillion in goods and services. That created up to 22 million jobs by the time we realize the potential of this technology. And this massive explosion of the technology and connectivity will actually create a lot of interesting opportunities to many areas. And I list here a few pictures from virtual reality to safer autonomous transportation to more reliable networks to digitization and logistics, autonomous manufacturing, and so on. In all these areas that I talk about here, we are actually shipping 3G and 4G products. So these are not new use cases we're dreaming up, but they will be much better use cases when we get the next generation technologies. So I want to maybe motivate a little bit with a kind of experience which is now possible with the technology we have, and will be a lot more exciting when you get more bandwidth. For example, at this show at IFA, I was working with a company called Ricoh, and they launched this product a couple of days ago. It's actually it's called Ricoh Theta V. It's a product that kind of just looks like their previous generation product, but there's some very interesting stuff. This actually records in 360 degrees. So it's got two cameras, 180 each way, and you hold it up, and it's got Wi-Fi built in, and Bluetooth, and GPS, and all that. Just press one button, it starts recording. You don't really have to worry about where you're pointing it. It really doesn't matter, because it's recording all 360 degrees. And you just walk with it, and when you're done, you press another button, and you put in your pocket, or you just transmit it. Now imagine you're at a baseball game, and you're sitting in the front rows. You happen to get these front row seats, and you just pick up this and start recording. You can now transmit this 360-degree video over Wi-Fi, and we actually do all the processing. This uses one of our Qualcomm processors. It does all the processing on the camera, including stitching of the video into one stream, and ships it over the internet. So now if you're at home and you had this virtual reality headset, you can have the same experience. In fact, the camera records using 4 speakers in full surround sound. Now, you need the bandwidth to be able to transmit that, and you can do it on 4G today. But if more and more people started doing that, you probably want to get to 5G, because the bandwidth is going to be at a premium. So I actually want to, so that, to me, is a concept of a use case of a 4K recording and transmitting, and you can watch it. And the one on the right side of this picture here is actually a virtual reality headset, also made by a customer of ours called ODG in San Francisco. That one has a Snapdragon processor inside. It looks like a regular glass. You put it on, and you can actually watch full 360-degree videos. To motivate a couple of more use cases, I'm going to play a little bit of video, and you'll see maybe the kind of use cases that are possible with technology today, but can be accelerated significantly when we get to 5G. Okay, it's a little bit of a product pitch, but really talk about what we can do with technology today. I mean, these are actually products that we have today. We can record in 4K video, transmit it wirelessly, and you can watch it on a headset. So when you get to that kind of use cases, you can see how compelling things like VR and things like 360-degree video cameras can actually, what kind of experience you can deliver. Now, I want to talk a little bit about mission criticality. You know, one of the other reasons about communication and connectivity is there's always this concept of how much do you want to compute on the edge versus how much do you want to compute in the cloud. However way you look at it, you want to make sure that you have a very fast, means of communication, and not only fast, extreme low latency means of communication to use the services on the cloud. Because in many use cases, for example, automotive, with the V2E. As you start thinking about autonomous driving, or even as you think about assisted driving, it's great to have access to the information in the cloud so you can make these decisions really quickly. So if you have the right combination of communication at the edge and on the cloud, and a very low latency link, these kind of mission critical applications can be done really well. It's almost essential to have this kind of bandwidth to really make these kind of technologies happen in the next generation. And another mission-critical application, which is actually not that too far off, is we are spending a lot of time on building technology into drones. I mean, these drones can navigate autonomously now, go over long distances, and some of the drones we are working on now at Qualcomm have an LTE modem built into them, so they can fly non-line of sight. And when you have a non-line of sight down at a mission-critical application, you really want that to be very reliable. You want that link to be solid, that doesn't go down because someone else is transmitting a VR video on a 360-degree camera. So you want to make sure that this bandwidth gets priority and so on. So those are the kind of things that we are working on 5G is to provide that low latency mission-critical nature. The third aspect of 5G we are working on is actually the concept of massive IoT. If you actually think about the potential of what we are able to, or what we will be delivering in the next few years. I mean, if you just look at our cities, there really is no reason why anybody should be looking at hunting for a parking spot. It just doesn't make any sense, because almost every parking meter has some form of solar panel, or they have some credit card access, so they're all connected. And your cars have modems. So as you start driving, every car should know where the empty parking spot is. It's really not an issue. We should not be sending people to check the electric meter. We should not be knowing when water is leaking in our water systems that are transmitting across the water all over our infrastructure. So the air quality index, when you actually start turning on things that get the air better, air conditioners when they actually turn on, freeway lights when they should be on and off. The applications in our cities, making our cities efficient, are just obvious, and the economic gains are huge. That's one of the reasons why we see a lot of people launching these. But when we launch IoT at that scale, and now we're talking about massive amount of things being connected. Now, they're all not going to be transmitting high-definition video or taking a lot of bandwidth. A lot of them may be battery-operated devices that just come on every so often, send what they need to send, and go back down. We need a network that actually scales with that kind of large amount of connections, which send a little amount of data for a short period of time. And that's another aspect of what we're working on, making sure the 5G network has. Now, I want to talk about LTE and LTE IoT, although I did want to talk a little bit more about 5G, the theme of this conference being what's coming up next. There is a lot of work we are doing in setting up these networks with current existing LTE networks. Ubiquitous connectivity, ultra efficiency, massive scale, all these things that we're talking about, we actually have products that are now launching, and more things are getting connected. For example, the 360-degree camera I showed you guys today, another company called Acer just launched at this show, exactly same camera, similar camera, but with an LTE modem. So you can actually transmit it without being on a Wi-Fi network. So LTE standards, there's a few standards that the standards body has built. We started with the release 10, 11, and 12. Now we came up with the LTE Advanced Pro that has all those other technologies. And now 5G NR, the new radio, is building on top of that. And we think by 2020 and 2021, that's when the full deployment of 5G will be. But we will see the first instances of 5G like in 19 and 20, which is not that far away, which is only a couple of years away when we get to this. OK, so I want to switch gears here and talk a little bit about, I know there's probably a lot of conversation about AI and machine learning, and really no No conversation seems to nowadays be complete without that. And what we are finding at Qualcomm is actually applications that are here and now that use machine learning tremendously. Just like that. Like, for example, we work with our partners to launch a security camera, I think by a company called Nest, which is a Google company. And it's so funny, the cameras before that, if you had that camera and put it outside your house as a security camera, it connects on Wi-Fi, and you can get notifications when things move or someone's at the house and so on. But the new camera, amazingly, records in 4K, but more importantly, it takes the high resolution 4K image and switches and finds if there's a person in the camera and matches that with the people who live in the house, and you only get a notification if someone who doesn't live in the house shows up. So it's a very typical application of machine learning at the edge, where instead of if you sent all this information to the cloud at 4K and started processing there and coming back, you'd never have the immediacy or the latency or the bandwidth to do it. But once you put a powerful processor at the end of the network, suddenly you have this ability to actually recognize exactly. And if a glass breaks, it can detect that some kind of glass broke, and you get a notification. If it's just your neighborhood dog running around, it doesn't set off any alarms. If the tree is waving in the wind, it doesn't do it. So just a simple use case like that, where suddenly the cameras you put outside your houses are a lot smarter. You can see drones that navigate autonomously. Cars that navigate autonomously are just thermostats that know what temperature you want the house to be, so you don't have to keep doing that. So a lot of applications we are seeing now with machine learning, and what that's doing is, to run the complex machine learning operations, what used to be devices that only needed some form of connectivity to connect to the network, actually now are needing both connectivity and a processor to actually do all this. So we are now at Qualcomm, and I think a lot of other chip companies are having to not sell not just connectivity devices and sensors, but pretty heavy processors into a lot of these devices. So we were surprised when we launched this product that this uses one of our high-end Snapdragon chipsets. It's a few $100 product. But the power consumption of this product is the same as the previous generation. All the performance is 4x. So that's actually the technology that we've been able to build in mobile, because we had to do it for the smartphones. But now you're finding all these other products using that technology. And that's one of the reasons why we see that IoT is accelerating as fast as it is. Now, security is very, very important. And I want to say a couple of things about this. I get a lot of questions asked on security. How do you feel? How do you make sure these things are secure? You can never make sure anything is like 100% secure. I think what you can do is make sure it's so painful to get into it, it's not worth it. That's kind of like literally what we try to do. And if you look at mobile phones today, I've been in the mobile phone business for a long time. And I remember when we first started, you could not even get high-resolution video content. You could not get an HD movie to watch on your mobile phone, because all the content guys felt we needed so much security to give the HD content. And the only way you got HD content is if you had one of the set-top boxes at home that had an encryption and a key. Now you don't even think about it. You just launch HBO Go on your tablet and you watch it. You watch the Game of Thrones and the day it comes on your phone. How did people suddenly get comfortable with that? Now you look at things like Netflix, and now you look at the first-run movies that you can buy in so many places. So we have built that security into these phones so that bitstream is secure all over, the memory is secure all over, and people can't really get access to that without a lot of pain. People used to talk about banking. I mean, you would not think of, people are worried about putting their credit card number on the internet. Now people just buy with their phones, with Apple Pay and Samsung Pay and Android Pay. So we've now built that security to the point people trust their money and the banking system with the phones. And that, since I've been associated with it for a while, that has happened because there is a lot of technology that goes into the chipsets that are inside your mobile phones. For example, we have a trusted execution environment. We have secure boot. We have hardware crypto engines. We have secure debug, secure storage, secure key management, and a lot of wireless protocol security. So the phone that you take for granted has tremendous amount of security built into it. That's why you see all these applications now working. So our job now, what we're doing is to take that class of security and putting it into all your other IoT devices. So you can kind of trust them in the same way that you do trust your phones. My last slide here is actually more of a reach out call or a plea to all the audience here. The difference between IoT and the difference between mobile phones is when we did mobile phones, for companies like Qualcomm, we had to work with the operators. We had to work with the phone makers. And you could count on maybe 2 hands all the number of people you had to work with. There are a few companies that make phones. There's a few operators around the world. And it was good. Now, in IoT, it's a completely different story. There's hundreds of customers, thousands of customers that want to make these products. And a lot of them, their strength is not really in the technology that we provide. Their strength in making user devices, making things that are easy to use, making things that solve problems that are very different from the phones. Now, so the challenge for us now is to make sure that we deliver this technology that we built in phones in a way that it may be consumed easily by all these other companies. For example, we want to launch a bunch of watches here from the likes of Michael Kors and Louis Vuitton and so on. They're not technology powerhouses, but they were able to take Qualcomm technology and launch it. And that was done with the help of software platforms, cloud ecosystems, modules, a bunch of partners working together with us. So the main thing to me is we have to work together with a lot of people with a lot of different technology and a lot of different services in different industries to launch the IoT products. And that's going to be a different kind of operation than phones or PCs. So my last slide here, I think that as an industry, with all the work we've done in mobile platforms, we are kind of set up uniquely to drive this next generation of connectivity, compute, and security. And I think as long as we keep in mind that the purpose of these devices that we build is to solve some function and make somebody's life easier, and not just technology for technology's sake, I think we'll have a lot of great products and it'll be a lot convenient place to live. Thank you. It's my last slide.